this exam. 好，我们先继续把第5章的一些内容讲一讲，再回过头来把第4章我们上次没有认真讲的这个 conical refraction 的这个花点时间把它讲完整。好，那我们先继续讲第5章内容啊。那我这边简单复习一下我们上次所学到的啊。So last week we learned in chapter 5 that when we have a piece of crystal, anisotropic crystal, then if two principal axes are parallel to the surface and one perpendicular to the surface, then if the two principal axes corresponding to two different refractive indices, then we can use this plot of crystal to do something to change the polarization of the incident light, and we make it as a wave plate. So the use of wave plate is to change the polarization state of the incident light. Then usually we name the two corresponding refracting indices as NS and NF, and we name this axis corresponding to NS as slow axis, and the axis corresponding to NF as fast axis. And the third axis is perpendicular to the surface of the wave plate. Then, if we send a beam of light with specific polarization normally into this wave plate, then since the polarization can project onto the slow axis and the fast axis, and the two components propagate with different phase velocities. So after penetration through this wave plate, the two components get two different phase vectors. Then if we combine that together, then finally we get the final polarization different from the incident light. Okay, that's why wave plate can change the polarization of the light. 就说你以正向路射一道光有一个特定的偏振，这偏振可以分出两个分量，一个分量是投影在慢轴，一个投影在快轴。那慢轴、快轴对应到的相速度不一样，所以这两个呢，因为相速度不一样，穿过这一块wave plate 之后所累积的相位不一样。那这个相位差就导致最后叠加出来的新的偏振跟原来的不一样，那就改变了这个偏振状态。这就是 wave plate 的基本工作原理基本功能。So that's the basic working principle for wave plate. In this way, we can calculate the final polarization state of the light. And in the calculation, usually we ignore the possibility that some parts of the incident light will be reflected by the interface. 就有些时候，我们通常是忽略了这个反射，忽略反射。那忽略反射的意思就是说，你相信几乎全部的入射光全部都穿透到wave plate里面。OK， 那如果你用这样的近视去看的时候，这个wave plate所做的事情只是把偏振转来转去，它并没有去改变这个polarization的大小。 强度，并没有改变它的强度，改变它的偏正状态。那数学上对应到这个，就是说这一块 wave plane 的数学描述是一个所谓的unitary transformation。unitary transformation 所做到的事情就是，你只把向量的这个方向跟那个相位改来改去，但是你并没有去改变它的长度。OK， so mathematically we describe the function of this wave plane as a so-called unitary transformation matrix. Okay, and this means that after multiplying this matrix, the original vector just changed its direction and phase without changing its magnitude. Okay. If the matrix has such property, we name such a matrix as unitary matrix. 就是说数学描述上就是这样那有一个稍微有点麻烦的地方，就是说，我们虽然参考这个慢轴、快轴去思考问题的时候，其实还蛮简单的，就这么简单。但是呢，我为了把它表达在所谓的实验室坐标系的话，那就会稍微麻烦一点。就是说，我们还要再做一次投影，把它投影到所谓实验室坐标轴。那这里面就会牵扯到数学的表达上，会放入一些所谓的旋转矩阵，使得那个关于 wave plane 的数学描述就变得稍微复杂。So, if we consider the result just using the principal axis, then the analysis can be very simple and easy. However, usually we need to consider the problem in the so-called level frame. Then we must use the so-called rotation matrix to calculate the result in the crystal frame. We change the result in the crystal frame to the level frame. Okay, then so the mathematics description becomes a little bit more complex. Okay, 好，所以这边呢就变成说，我们有一个所谓的实验室坐标 x y are the two coordinate axes in the lab. Okay. The angle between the slope axis and the x-axis is denoted as phi. The z angle between y and the first axis. Okay. And we have the rotation matrix. Rotation matrix is denoted as R. 我用 phi 还是用 phi 呢？我看一下我不是用 phi 啦，我们用 psi， 抱歉的。Sorry, we use psi to represent the angle between the slope axis and the x-axis. So we have R psi. R psi is written as cosine psi, sine psi, minus sine psi, cosine psi. Okay. So mathematically, this wave plane can be represented by a matrix W. W 的意思，英文就 wave plane， wave， 所以 W wave plane 那it can be written as R minus psi times W0 times r psi. Okay. W0 is in fact equivalent to W, but W0 is the function of W observed in crystal frame。就是说，如果我们今天用的是所谓的晶体的这个坐标系统的话，那这个 W 就直接表达成 W0、W0 W0。W0 is the effect of the wave plate in the expressed in the crystal frame. Okay. However, if we want to translate the expression from crystal frame to lab frame, then we must consider these two rotation metrics to change the expression from the crystal frame to the lab frame. 所以假设你能够在 crystal frame 里面直接思考，那结果就会非常简单。但是如果你不会做这件事，那至少你也可以很机械化的用这个公式把结果算出来。So if you have the intuition and you know how to think the problems in terms of the crystal frame, then the analysis is in fact very simple. However, if you do not know how to do this, then at least you can follow the rule and do the mathematics carefully. Then finally you can still get the correct result. OK， 好，那这里呢，这个 W0 是什么 ？Here the W0 is this exponential minus f gamma 0 0 exponential I f gamma. You do not need to consider the overall phase exponential minus I phi. This phase factor is in fact useless. So usually we do not need to consider it, and we can just drop it. Okay. And what is gamma? Gamma is this ns minus nf times omega L over C. Okay. You see, in fact, what is ns? Ns times omega over C is in fact this Ks. Okay. And nf times omega over C is nothing but Kf. So this quantity is in fact this Ks minus Kf times L, or you can see this as KSL minus KFL. Okay, KSL is the phase difference for the slope axis. Okay, you send the beam of light here, and then you penetrate through this wave plate. The thickness of the wave plate is L. Then the final light, the phase of the light after penetrating through this wave plate, when compared with the incident light, it gets this phase difference, phase aggregation. And for the fast axis, we also have this phase aggregation. Okay, then we take the difference of them. The difference tells us what the final polarization is. Okay, you remember that in chapter 3, the overall phase is has nothing to do with the polarization. Okay, because we can always drop them out. 就是你把一个 polarization 乘上一个整体的 phase vector， 并不当成不同的 polarization。就是比如说我今天这样子比如说我有一个 polarization 是1，跟号2分之1。那你换成比如说这边乘上一个 i， 这两个是视为相同的 polarization，same polarization。Only the phase difference between these two components determine the polarization state. Okay, this external overall phase has nothing to do with the definition of the polarization state. 就是说，那个整体的 phase factor 一点都不重要所以这就是为什么我们可以把这个部分擦掉不管。That's why we can ignore this exponential I phi and just consider W0 as this diagonal matrix. Okay? And so finally, if we initially have polarization given by V, V is Vx, Vy, and the final polarization is V prime, Vx prime, Vy prime. Then V prime is related to V by W. V prime is equal to W times V. And then this is just R minus psi W naught R psi times V. Or more explicitly, you can write this as Vx prime, Vy prime is equal to cosine psi minus sine psi, sine psi, cosine psi times exponential minus half gamma 0, 0 exponential half I gamma times cosine psi, sine psi minus sine psi, cosine psi. Okay? This part gives us the physical effect on this polarization. These two parts tells us how to express the result in the original lab frame. OK， 好，这个就是等一下这边还缺了一个 Vx Vy。OK， so Vx Vy prime this times Vx Vy。好，那since W naught has this property, this notation dagger means taking the complex conjugate and doing the transpose. Okay, then W naught dagger is nothing but this one. And we know that here this vector is the inverse of this vector. And this vector is the inverse of this vector. So W naught vector times W naught is equal to identity matrix or unit matrix. And from this result, we finally find that W dagger times W is also equal to unit matrix. And this factor tells us that W matrix is so-called unitary matrix。好，这个就告诉我们说它是这个所谓的 unitary matrix。那如果今天我们考虑的问题，如果是真的有考虑到这个有反射的情形的话，那这个东西的数学描述其实没有那么简单啊。那时候我们不是用2×2矩阵来描述，而要用4×4矩阵。好，然后我们的这个 violation state 呢，它就会变成有注射波的 violation 跟反射波的 violation， 就变成4×1的vector 啊。If we consider the effect of reflection, then we can still use matrix algebra to discuss this problem. However, in that case, we should take in the reflection wave into consideration. So the color vector becomes 4×1, where we have the polarization state of incident light and the polarization state of the reflected light. Okay, and in that case, the W matrix becomes 4×4, and in that case, W matrix becomes non-unitary because some energy be reflected back 就是说在这个情况之下呢，W 就不再是这个情形了，就它会变得比较复杂。好，那我们到目前为止，我们都用这个unitary 的方式去想它好，除了 wave plate 之外呢，我们其实还有一种东西呢，它就不是 unitary matrix， 但是呢，一样在这 4×4 里面是有用的就是所谓的 polarizer The mathematical description of a polarizer is very different from the representation of waveplate because polarizer filter out the useless component of the wave. Okay. For example, we have a polarizer like this. If we send a beam of light and the light has the polarization parallel to the so-called passing axis, then it can penetrate through this polarizer. However, if the beam of light has the polarization perpendicular to the axis, then it will be absorbed completely. So in this, if we consider this property, then we can say we can denote say if the polarizer allows the wave, the x component, x polarization of the wave to penetrate through it, then we can denote it as px and represent it by 1, 0, 0, 0. This is the x polarizer. X polarizer means it allows the x polarization to penetrate through. Okay, and X polarization can be represented by 1, 0. Okay, then you see that Px times X polarization is equal to 1, 0, 0 times 1, 0, and this gives us the original 1, 0, the x polarization. Okay, and if we multiply if the y polarization polarization is represented as 0, 1. Then we see that px times y is okay. This means that the polarized field absorbed the y polarization line completely. Okay. So now you can easily understand the y polarizer can be represented as this matrix. Okay? Because now you can see that py times x is 0 and py times y is y. 好，这个是关于 polarizer 啊。就偏正片啊，偏正反，然后这个the mathematical description of a polarizer, usually we call this kind of matrix projection operator. Projection operator. Projection matrix. Okay. A projection matrix has this property that px squared is equal to px. Py squared is equal to py. 好，比如说它平方之后呢，它跟没有平方是一样的啊，因为就是你已经 project 之后啊，比如说你原来有一个光经过 project， 你只留了一个分量，对不对？然后你在同样的方向上，你再 project 一次，它就是无保留的，跟第一次 project 出来的结果是一模一样的啊，所以平方会跟一次的是一样的啊。那现在如果我把这个 px 去乘上一个任意的偏正会怎么样啊 ？So if I multiply px with an arbitrary v, v has the two components vx and vy, and this gives us vx 0, which means only the x component is left, and the y component of the polarization has been absorbed completely. 啊，就它就完全被吸收掉。那我们现在来问一个问题，就是我如何表达一个任意方向的 polarizer？ 就是说我让这个所谓的 transmitting axis 朝向任意方向。好 ，if the transmitting axis of the polarizer makes an angle with respect to the x-axis. The angle is psi. Then how to represent this polarizer mathematically? Then this polarizer, if I denote it as p psi, then p psi is nothing but r minus psi px times r psi. Just like what we do to the wave plane, but replace W0 or W0 by px. Okay, so this means that this is equal to r. This is equal to cosine psi minus sine psi, sine psi, cosine psi times 1, 0, 0, 0 times cosine psi, sine psi minus sine psi, cosine psi. Okay, you can multiply them and find the final result of the representation of this wave plane. 好，这个是关于一个 wave plane。好，我们举个例子来讲好。For example, psi is equal to 1/4 pi. Then we know that now cosine psi is equal to 1 over square root 2. And sine psi is also equal to 1 over square root 2. Okay? Then for this situation, we have P 1/4 pi equal to this one. Okay, and this is equal to okay. So you see that if now I multiply it with an arbitrary incident polarization, we get 1/2 bx plus b1 times 1. So if bx is 1 and by is 0, then we get 1/2. Okay. 就是说，它就会变成是变小了变小因为有一部分能量被吸收了嘛你看我们本来如果是原来的有 v 的绝对值本来是1嘛，本来是1，那 v prime 的绝对值呢就变成是1/2，变成1/2，因为缩小，因为有一部分被吸收掉A part of the light has been absorbed by the polarizer. 好， 那我们现在来具体的举一些例子。Example. Half wave retardation. 这个是叫做 half wave retardation plate 啊。什么叫做 half wave retardation plate 呢？这个情况就是伽马等于派。好，就是如果是2拍，我们就当做好像是一整个波长；那如果只有拍的话，我们就当做是只有半个波长。好，所以伽马等于派 or 奇数拍其实都是，好，奇数拍的话，其实效果是完全的，啊，效果其实是完全的。如果是伽马是奇数拍的时候，我们就叫 half wave plate。那如果是 half wave plate 的时候呢，这时候 W 会等于什么？在做这个说明之前呢，我们讲一下通常的设定啊。实验上通常的设定是这样，就是我们通常会把鳃整个固定下来，固定成45度。So usually for the use of half wave plate or quarter wave plate, we set the psi to be 1/4 pi, which means that the slow axis and the fast axis the angle between the slow axis and the x-axis is 45 degrees. Okay. And gamma is equal to r integer times pi. If we know ns and nf, and we know omega, the frequency of the light or the wavelength of the light, then we can choose the correct thickness of the waveplate so that we get gamma equal to pi. OK， 好，就是说我们对于操作的波长呢，折射率。波长、频率这些我们都知道的时候，我们可以倒推说我们要什么样的厚度啊，它会对应到伽马等于派啊，或者是厚度，如果是我们不能调控的，我们可以调波长或频率，调到伽马刚好等于派啊。So if we cannot change the thickness of the wavelength, then we can change the wavelength or frequency of the incident light. So we can find a proper frequency or wavelength that waveplate gives us gamma equal to pi. Okay. Then once we have this result, then W is equal to this. Minus I, 0, 0, I, here we have used this factor, exponential minus I gamma over 2. Now, gamma is equal to pi. And exponential I half pi is equal to I. And minus I half pi is equal to minus I. Okay? And this is equal to I. Okay. So here we have this minus I, and you can multiply them to get the final matrix 0 minus I, 0. Okay. You can see that here we can factor out the minus I and get the matrix 1, 0, 1, 1, 0. Okay. If you know something about electron spin in quantum mechanics, then you may know this matrix is the Pauli matrix sigma x. Sigma x, Pauli matrix. Okay, and this matrix has the effect that exchange the x and the y components of the vector. So if we multiply, if we choose v to be 0, 1, okay, usually we choose the polarization of incident light to be along the y direction, y polarized light, and we set psi to be this 1/4 pi, and we can find the final polarization state as so you see, originally we have a y polarized light, then finally we get an x polarized light. Okay, so this means that we rotate the polarization 90 degrees. 我们把它从 x 偏正变成了 y 偏正，y 偏正变成了 x 偏正。This factor, this minus I factor, as I have already explained to you, has nothing to do with the judgment about what the final polarization is. 这个 minus I 跟最后是什么偏正没有关系，那是多余的 factor 多余的 factor。好，那我们其实可以非常简单去了解这件事。In fact, if we consider this problem in the crystal frame, then the result can be very easy to understand. Okay, you see that originally we have this y polarization state. So if you project the y onto the slow and the fast axis, then both components are equal. Okay, we have two equal components projecting on the two axes. And after the penetration through this wave plane, the phase difference between these two axes is pi. Pi means negative sign. The exponential I gamma is exponential I pi, which gives us minus sign. Minus sign means what? If we keep one component unaltered, then we change the original, the other component to its negative. Okay, so this means that suppose I keep this component unaltered, and I change this component to its negative. So finally, we can add them to get this polarization. Okay, so that's why we rotate the polarization by 90 degrees from y to x。哎，其实就是你用45度角来看的时候，它就是相当于说，你把一个轴的相位当做没变的话，另外一个轴的相位等于是变了派就是变负号，所以你本来是这样叠加的，是朝 y 的，变成这样去叠加就得到 x， 这样子啊。这是从crystal frame 来看，其实非常简单啊。但是如果你不会这样思考的话，至少可以照表操课，按这个公式去把结果算出来。 So that's the effect of the halfway plane. So now we see another example, 1.1.2. Quarter wave plane. A quarter wave phase means gamma is equal to half pi. Okay. Gamma is equal to half pi 就是2派的4分之一，所以我们就叫它 quarter 啊，就是你把2派当做一个波长，那2分之派就会是它的4分之一，所以就是 quarter 4分之一的意思啊。So if you choose 2 pi to be corresponding to 1 wavelength, then half pi means 1/4 wavelength. Okay. So W. Now we still keep the setting of psi equal to 1/4 pi. So now we have W equal to 1/2, 1 minus 1, 1, 1, and exponential minus I 1/4 pi. 0, 0, exponential I 1/4 pi. 1, 1, minus 1, 1. Okay. Then finally, you multiply the three metrics to get the final result is, sorry. The final result is this. Here, we use the factor exponential plus minus I 1/4 pi is equal to this 1 over square root 2 1 plus minus I. Okay, you can use Euler's formula. Exponential I theta is equal to cosine theta plus minus I sine theta, okay? And substitute theta equal to 1/4 pi into this expression and you get this result. Then use this result, you can find the final result. 好，那我们这边先下课一下。So we see for quarter wave plane we have this W, and the final polarization is equal to this 1 minus I 1 times 0, 1. Okay? And the result is minus I 1. And we can factor out this minus I to get 1 I. Okay. So as I have already explained, this minus I is not important. So this is equivalent to this. And what is this? This is the left circling polarized light. Left hand circularly polarized light. 所以它就变成是no right sorry left or right yeah left okay 好，那这个东西其实也很容易理解啊。你看啊，就用我们刚刚同样的思考方式哈，我们 y 方向送进一束光，然后有 y 偏振的光分解成两个分量，然后其中一个分量不管，然后另外一个分量呢差2分之派的相位啊。那我本来是这样子的，本来是1变成根号1/2的1嘛，然后把第二个呢补上一个 I 的相位，就变成根号1/2的1I， 那不就变成圆偏振了啊 ？So originally, we have originally we have y polarization, and the y polarization is in the left frame. Y polarization in left frame is polarization, this polarization in the crystal frame. Okay. And we have this crystal frame, which is left hand circularly polarized light. What is the difference between the expression of left hand circularly polarized light in crystal frame and in left frame? The difference is just this phase vector, exponential minus ik. Okay. 好，这个东西的话呢，就是说你从一个坐标到另外一个坐标呢，其实就圆偏振来讲，它的那个 polarization 的表达方式看起来是没有差别，唯一的差别就是这个额外的 factor 啊，但是额外的 factor 其实并不影响关于 polarization 的判断啊，所以它还是被称作 left hand circularly polarized light。OK， 好，那好，讲完这些之后，还有一种东西叫 four-way play，four-way play 就没有做任何事了哈。We also in some situation we also encounter four-way play. Four-way play means gamma equal to 2 pi, and if you consider gamma equal to 2 pi, you will see that this wave plate does not change the polarization of the light. Keep the polarization the same. Four-way plate. So now we consider the combination of polarizer and wave plate and see what we can do to not just change the polarization but also influence the transmittance of the wave。我们现在把波片wave plate 跟这个偏振片做一个结合然后看看我们能用它来做些什么事情So now we consider intensity transmission. Okay, here we combine wave plate with the polarizer. 要怎么样去做这样的事情呢？就是说，我们可能让光先通过一个 polarizer， 然后经过 wave plate， 然后再通过第二片 polarizer， 然后去看最后通过多少。First we have the original polarizer whose transmission axis be along some direction. Then we consider wave plate whose two axes, slow axis and fast axis slow and fast axis makes 45 degrees angle with respect to the x-axis. Then finally, we let the light penetrate through the or absorbed by the third polarizer. And finally, we ask what is the transmission? What is the transmission? 好，我们最后这个 polarizer 的方向呢，可以跟原来的一样或者不一样这个都随我高兴看我们的设定是什么然后在称呼上呢，我们有时候会把这两个 polarizer 给它不同的名称这个入射这一端的 polarizer 我们叫 polarizer， 然后出射端的我们叫它 analyzer。Okay. In fact, polarizer and analyzer are both polarizers. Okay. However, usually we call this one polarizer and call this one analyzer. Okay. This polarizer is used to prepare the incident collision state. Okay. And we use this wave plate to influence or change the polarization state of the incident light. And finally, we let the light to penetrate to the second polarizer, the analyzer, and see what the resultant transmission. 我们就总之这样子的话呢，我们可以去分析这个最后的这个穿透系数或者说这个穿透率那只有一片的时候，你可能觉得说这好像有点无聊，不知道在干嘛但是呢，如果我们中间有很多片的 wave plate， 然后以某些方式去设定它的时候它就可以做一些非常有用的事情，比如说一些filter 可以把某些特定频率的光给滤出来然后其他频率不对的光呢都不会通过那个我们之后会再讲So how to consider first we originally we have the polarization described as EX and EY. Okay. This one is in fact the light after penetration through the polarizer. Here we have this E. Here. We may originally send a beam of polarized light into the polarizer. Okay? And this polarizer polarizes the light into this polarization state. And in between these two polarizer, this wave plane change the E vector. And finally, after penetration through this analyzer, we get the final polarization E prime. And final, this is the just the polarizer. Just okay， 好，就是在在第一片 polarizer 后面我们看到的是这个，然后呢 ，final 你还是写 after 好了。这样，然后我们就可以定义这个所谓的 transmission. Transmission is defined as E prime dagger E prime over E dagger E. That's because the intensity is defined as E dagger E. And the final intensity is defined as E prime dagger E prime. Okay? Or we can write this as E x prime square plus E y prime epsilon square over E x epsilon square plus E y epsilon square. Okay? 好，这个是我们可以用来计算所谓的 transmission 就是它究竟通过了多少通过了百分之多少好，那我们现在来看一个具体的例子Example by reflection to play the sandwich between parallel polarizers. 我们现在来看一个例子。 Now we see this example. 好。那我们这边看的是5.2.1这个 example 啊。By refrigerant plate sandwiches between parallel horizons 啊。那这个 wave plate 本身的这个 retardation 呢，这个 gamma 呢是任意的啊。We now have an arbitrary gamma. Gamma is just this. We see that is Ks minus Kf times the thickness. Now the thickness is given as D. 刚刚我们都叫 L 嘛，这边叫做 D， 没差啊，就是但这边给的例子就是叫做 D 啊 ，D is the thickness, and this is equal to omega over C times Ns minus Nf times D. And Ns over omega over C is the K naught in the vacuum. K naught is just the 2 pi over lambda. Okay. So now if now we use the positive uniaxial crystal, if we now use positive uniaxial crystal, then now Ns is equal to Ne and Nf is equal to No. So this can be written as gamma now can be written as 2 pi over lambda times Ne minus No times D. Okay, this is the formula 5.2-5 in the textbook. Okay. 好，那我们基本上是改变入射的波长呢，就会改变这个 gamma 啊。Here lambda is the wavelength in vacuum. Lambda 是这个光的在真空中的波长啊，因为它在介质中不同介质有不同波长。我们这边讲的是它在真空中的波长啊。好，那如果是这样的时候，我们的 W 会长成什么样子 ？So now what is the W? We still choose psi to be 1/4 pi. Then W now becomes and now we can write this as And this gives us plus sign. Plus sign, 1/2 is just equal to cosine. Okay. And minus sign times 1/2, this is I, minus I sine half gamma. Okay. And this also gives us minus I sine half gamma. And finally, this is cosine. Cosine. This one. Okay. Here we have used the fact that cosine theta is the exponential I theta minus plus exponential minus I theta over 2. And sine theta is the exponential I theta minus exponential minus I theta over 2I. Okay. 2I.好，那我们现在 W 算出来了。那接下来呢，我们就来算一下这个 transmission。So now we have so now we have this W. Then suppose originally we have a beam of unpolarized light. Okay. After penetrating through this polarizer, this light gets polarized along the y direction, and the strength becomes 1/2. So, if originally we have strength equal to one unit strength, then the amplitude becomes 1/√2 and polarized along the y direction. Okay. And so the final E becomes EY 0001 and times W cosine half gamma minus I sine half gamma minus I sine half gamma cosine half gamma. Okay. So the final E is equal to 0 minus I sine half gamma cosine half gamma times this one. Then we get 0 cosine half gamma. Okay. So the final strength of the light is equal to E prime dagger times E prime, which is 1/2 cosine squared half gamma. Okay, and according to the definition of gamma, this is just equal to this 1/2 cosine squared pi NE minus NOD over lambda. Okay. We can further write this as 1/4 cosine gamma. Use the double angle formula 这边就是 cosine 平方 theta 可以写成1/2的 E 加 cosine 2θ。好，那如果我们对它做图的话呢，其实会得到一个像这样的图。So if I plot gamma with respect to the intensity or strength of the light, then when gamma is equal to 0, we get the highest point. Then when gamma is equal to half pi, we get half of this highest value, maximum value. And when gamma is equal to pi, we get 0. Okay, and the result is just like this. Repeat periodically with respect to gamma. 这个就是强度，对，强度的变化，强度的变化。好，那我们再看另外一个例子。Now we see another example. In this example, we change the transmission axis of analyzer from Y to X. Okay. So if we change analyzer from PY to PX, this means that we change these matches. And this is equal to cosine half gamma minus I sine half gamma 0, 0. And here we have minus I sine half gamma 0. Okay, and this gives us one half sine squared half gamma, which is 1/2 sine squared, this one. And the sine squared gives us here a minus sign. And this minus sign tells us that this is equal to this curve. And the sum of these two possibilities gives us 1。好，这个其实也很合理了啊！你看，这种选择跟刚刚那个选择刚好是互斥的选择啊，就我要让 x 分量通过，跟我要让 y 分量通过是2种互补的选择，啊，所以在第一种情况下被吸收的，就是在第2种情况下通过的。OK， 好，所以这2个加起来等于是没做任何事，啊，是一样，就等于是全部都通过，啊。好，那这个是关于 wave plane 加 polarizer 的一个结合的运用，啊，那后续呢，其实还有所谓的polarization interference filters 啊，但这部分比较复杂，我们等期中考之后再来讲这部分。好，那我现在退回去第4章，讲一下我上次没有讲完的关于 conical refraction 的部分。好 ，so I left section 5.3. 5.4, etc. To next week, which means that we will teach these parts after our midterm examination. Now I go back to chapter 4 to complete the introduction of conic refraction that I haven't finished last week. (那我们考试也就考到我们刚刚所教到的部分啊，包括我现在要教的部分呢，也会考到。So our midterm exam includes all that I have already taught and the materials that I will teach till today. Okay. 好，那我们现在来具体讲一下关于这个 conical refraction 啊。在讲那个之前，我们再复习一下，在所谓的这个biaxial crystal 里面的情况啊。So now we consider the biaxial crystal. We assume that nx is smaller than ny, and ny is smaller than nz. Then we know that the normal surface intersects with 3 coordinate axes. The intersection includes 1 circle and 1 ellipse for every coordinate plane. Okay. So, for example, the kx, ky plane, we have this 1 small ellipse and 1 big circle. One small ellipse and 1 big circle. The radius of the big circle is nc omega over c. And the shorter semi-major axis of the ellipse is nx omega over c. And longer semi-H major axis is NZ, Ny omega over C. Okay, and we see that this point corresponds to the situation that the B vector is pointing along the Z axis, okay, and the K vector is pointing along the Y arbitrary propagation direction, because this is a sphere. So if you have an arbitrary propagation direction, but the B vector is along the Z axis, then you get reflecting that is equal to NC, and this corresponds to this circle. Okay, and if you have the B vector along the X direction, here this is the X direction, here this is the Y direction. Okay. If you have the wave vector along the Y direction, but the E vector and B vector along the X direction, then this corresponds to this point, which means the refracting index now is equal to Nx. And for this, we have a K vector along the X direction, but the E vector and the D vector along the Y direction. Okay, so you have the refracting index equal to Ny. Okay, and since Nx is smaller than Ny, and Ny is smaller than Nc, so we see that the largest is the circle of radius Nz omega over C. Okay, and for Nx and Ny both smaller than Nc, so this ellipse is smaller than this circle, so this ellipse is inside this circle. Okay. Now in the KY KZ plan, KY KZ plan, then we have this KY and KZ. So here we know that we have a small circle and we have a large ellipse. Okay, and here this semi-major axis is equal to Nz omega over C. And this semi-major axis is equal to Ny omega over C. And the radius of the circle is Nx omega over C. Okay, so the circle is the smaller curve inside this ellipse. And the ellipse has two semi-major axes equal to Ny omega over C and Nz omega over C. Okay. And finally, in the KX-KZ plan, the KX-KZ plan is the most interesting part, because now we encounter the so-called optic axis, two optic axes. Now, in the KX-KZ plan, we have we have the circle its radius is equal to ny omega over c, and the semi-major axis of the ellipse are nc omega over c and nx omega over c. Okay, and now we have two optic axes. This is the first optic axis, and this is the second optic axis. We have optic axis 1 and optic axis 2. Okay. These are what we see as the intersection of normal surface and the coordinate plane, 3 coordinate planes. And in fact, a normal surface is a very complex surface with 2 shares, and it is not just the combination of a sphere with an ellipsoid. It's something different. But on these 3 coordinate planes, we indeed see 1 circle and 1 ellipse, 1 by 1。然后我们现在想要看一个什么事情？我们之前有讲过一个事情，就是说，我们如果要知道群速度就是这个光的能量究竟往哪里传的话，我们所要做的事情其实是什么？就是把 normal surface 的那个 omega 的那个形式取 gradient 那我们就会知道光往哪边传的话。So we have already introduced the idea of group velocity, which is the propagation direction along the propagation direction that the light beam propagate or energy propagate along the group velocity. Group velocity is the k gradient of the omega surface. Okay, and this means that the direction is normal to the normal surface locally. Okay. For an arbitrary point that is not too close to this 4 special point, locally we can treat a part of normal surface as a flat plane. It can be approximated by a flat plane, so we can find a very clear, very specific direction of speech. However, if we consider a region that is very, very close to this point, then locally, at this very special point, we have no definition of the gradient of omega or the normal vector, because locally it looks just like a cone. Locally, the region very close to this point, you see the normal surface just like a cone. Okay. At this point, we can have very clear definition of the normal vector. But at this point, we do not have such kind of definition of the normal vector. In reality, when we send a beam of light into the crystal, a beam of light is not an exact plane wave. So in fact, it includes not only one K vector, but a small range of the K vector close to some central K vector. Okay, so this means that when we send a beam of light and its central K vector is very close to this point, then we in fact encounter the situation that we consider a region very close to this point. So if the K is located here, we have this normal vector. And if the K is located here, we have this normal vector. And if the K is located here, we have this normal vector. And here we have this normal vector. Okay. So if you collect all the possible normal vectors, then we get another cone. We get the cone for the energy propagation. We get a cone like this. Get a cone like this. This cone represents the ray of energy. Okay. So since now light propagates along a cone, so if we have a block of biaxial crystal, and this direction is the direction of optic axis. Now we assume this direction is the optic axis. One optic axis, and this is biaxial crystal. Then I send a beam of light here, and it propagates along a cone. And finally, a ring is formed. If we project, if the light is incident onto a wall or screen, okay, and this ring-shaped refraction phenomenon is called Corning refraction. Okay. Then I will derive the details about the Corning refraction next hour. 那我们这边就先在这里下课一下。好，那在讲下去之前，我先把作业勾一下。 chat for homework. Conic refraction. So now I try to analyze the details of conic refraction. Okay. First, we need to find this reference k vector. This k vector. This k vector denotes the direction of the optical axis. Suppose the angle between this k vector, I can denote this k vector as k0. We denote this k vector as k0 vector. And suppose the angle between the k0 vector and the z-axis is theta. Then now we try to find the formula of this theta. Okay. So we can know what the k0 is. And then I will consider to work in the vicinity of k0, which means we choose k to be a little bit different from k0, but the difference is very, very small. Okay, so then finally we can find the cone equation locally. Okay. So first, we need to know the k0 point. We know that now optic axis, these two optic axes are in the kx, kt plane. So this means that the k0 point is just the intersection point between this ellipse and this circle. Okay. So first we need to find the equation of the circle and the equation of the ellipse. I just mentioned the result. The result is that the circle is described by k squared over ny squared minus omega squared over c squared. Okay, and the ellipse is this k squared, kx squared over nz squared plus kz squared over nx squared minus omega squared over c squared equal to 0. Okay. Here, this k squared is in fact kx squared plus kz squared. Okay, because now we consider only the points in the kx, kz plane, which means that ky is equal to 0. ky is equal to 0. Okay. So you see that the k0 point has the k satisfying both this circle equation and this ellipse equation. Okay. So for this, according to this circle equation, the x component and the z component of k0 can be written as k0x is the length, the magnitude of k0 is ny omega over c, and its x component is given by the magnitude of k0 times sine theta. Sine theta. Notice that now theta is the polar angle. This angle is the angle between this vector and the z-axis, not the x-axis. So here we have this sine theta. Okay. And the k0z is ny omega over c times cosine theta. Okay. So this parametrization is obtained by the fact that now k0 vector is in this circle, and it makes angle theta with respect to the z-axis. Now we must substitute this result into the second equation, the ellipse equation, so we can find what theta is. Okay. So if we substitute this and this into this equation, we see that now we have ny squared times omega over c squared times sine square theta over nz squared plus cosine square theta over nx squared minus omega over c squared is equal to 0. This is the form of the second equation. So according to this result, we can ignore the same omega over c squared and divide this equation by ny squared. So we see that now we have sine square theta over nz squared plus cosine square theta over nx squared is equal to 1 over ny squared. And now you remember that according to trigonometric function, 1 is nothing but the sum of cosine squared plus sine squared. Okay. Cosine squared plus sine squared is equal to 1. So now you see that now we have 1 over ny squared minus 1 over nz squared times sine squared theta is equal to 1 over nx squared minus 1 over y squared cosine squared theta. Okay? So tangent squared theta is sine squared over cosine squared, which is equal to this ratio, 1 over nx squared minus 1 over ny squared. Okay, over 1 over ny squared minus 1 over nz squared. And we can multiply the result by nx squared, ny squared, nz squared, nx squared, ny squared, nz squared. Okay, so this gives us nz squared times ny squared minus nx squared. Okay. And this gives us nx squared times nz squared minus ny squared. Okay. So tangent theta, which is a positive angle, is equal to nz over nx times the square root of ny squared minus nx squared, or nz squared minus ny squared. Okay. So this is the tangent theta. So we can we know what are these nx and y and nz. So we can use this formula to find the theta. Okay. And this theta gives us the direction of the optical axis. And once we know tangent theta, we can know second square theta. Second square theta is 1 plus tangent square theta. And once we know second, we know cosine, because cosine theta is 1 over second theta. And we can know sine theta. Sine theta is just cosine theta times tangent theta. Okay? So you can derive cosine theta and sine theta. And finally, you can find this K0x and K0z. 那我就不去推它了，但是呢，就是你可以自己把它推出来。So now my task is to find the cone equation close to this very special point. Locally, this point, the surface close to this point looks just like a belly button, 就是肚脐啊。这地方看起来像一个肚脐啊，就是它是一个这样子凹下去一个锥形的地方啊。那我们想把这个局部这附近的曲面的样子把它找出来啊。So now I want to find the equation that describe the surface very close to this K0 point. To do this, we need to consider the original Fresnel's equation of wave normal. And I find if I define some notation, then we can simplify the derivation. Okay. First, we know that we have K0 K0 is written as K0x, K0y, and K0z. And we know that K0y is in fact equal to 0. K0x, K0z. Okay. And now I define P0. I define P0 as this nx times K0x, ny times K0y, and nc times K0z, which is this. Okay. By the way, I also define P as nx times k, arbitrary k, kx, arbitrary ky, and arbitrary kz. I define P having these three components. So now I try to derive the Cohn equation from the normal surface equation. Okay. The normal surface is described by the Fresnel's equation of wave normal. Originally, it is written as Sx over Nx minus Nx squared plus Sy squared over N squared minus Ny squared plus Sz squared over N squared minus Nz squared equal to 1 over N squared. Okay. Here, Sx, Sy, and Z are the three components of the unit vector along the propagation direction of the phase, along the direction of k. K is written as n times omega over c times s, and s is sx, sy, sd. Okay, and n can be determined by solving this equation. And I have already shown that this equation can be rewritten as another form. We use this factor and do some algebra, then finally we see that this equation can be rewritten as this one. Okay, so Fresnel's equation of wave normal now can be changed into this form. And we can further multiply n squared minus nx squared, n squared minus ny squared, and n squared minus nz squared to this equation and find the fourth power quotidian equation for solving the refractive index. They are this n squared minus ny squared, n squared minus nz squared times nx squared sx squared plus n squared minus nz squared n squared minus nx squared, ny squared, sy squared, okay? And then n squared minus nx squared, n squared minus ny squared times nz squared sz squared equal to 0. Okay. Then we can collect the coefficients of each power to get the desired equation. So now this equation can be written as this form: a n fourth power plus b n squared plus c equal to 0. What is a? A is now equal to, we collect the coefficient of the fourth power, and we get this nx squared sx squared plus ny squared sy squared plus nz squared sc squared. Okay. And what is b? B have a negative sign, and here we see that we have summation of ny squared and nz squared times nx squared sx squared. Okay. So we have this ny squared nz squared times nx squared sx squared. Okay. This is the first term. The second term we have yzx zxy nz squared plus nx squared times ny squared sy squared xyz nx squared plus ny squared times nz squared sg squared. Okay, this is the coefficient b, and what is coefficient c? C is just the constant term. So we have nx squared, ny squared, nz squared times sx squared, nx squared, ny squared, nz squared times sy squared, nx squared, ny squared, nz squared times sc squared. And the summation of the three s squared component squared is equal to 1. So c is just the nx squared, ny squared, nz squared. Okay. So this is the fourth power of the quadratic equation, which we can use to solve for n squared. The n squared is this. And we can further take the root of it to get the two possible refractive indices. Okay. And now I want to rewrite this equation. I want to rewrite this equation. So finally, we can get a more suitable expression of this equation to be used in the discussion of conic refraction. 好，我现在要改写这个方程式，让它更适合我们讨论 conic refraction。然后在我的尝试之中呢，就是我发现定义这个 P 是有用的，定义这个 P 是对的。但在做那件事情之前，我现在先回顾一下，我们刚刚用到一个方程式是一个圆加上一个椭圆，那个方程式呢，我们现在可以来试一下，就是说这个，等一下啊，我先改写成那个我所需要的方程式啊，我怎么去改写？我怎么去改写这方程式呢？啊，这样子啊，我再多定义一个东西啊 ，I want to define capital omega as omega of c. Okay. So we can further simplify the expression of the result. Okay. So according to this result, now we have this. If we multiply the equation by this, the fourth power, we times the fourth power of omega into this equation. Okay. And know that now when we encounter n squared times omega squared, this is just n squared times omega squared over c squared, and this is nothing but k squared. Okay, so we can treat the fourth power of omega as omega squared times omega squared, and we can treat here n fourth power of n squared times n squared. Okay, so now we try to understand what is the result. First, we have omega squared times n squared give us k squared. And then we have omega squared times n squared times this. And what is this? This is just p squared, because n squared times omega squared times nx squared times sx squared. This is k squared, okay? And the k squared times sx squared give us kx squared. And the kx squared times nx squared give us px squared. Nx, kx is px. So the sum of these three square terms gives us k squared times p squared. This is for the coefficient a times n fourth power. And then we encounter a minus sign. And here we still have this omega squared times n squared. We have omega squared times we have only one n squared. So this n squared times omega squared give us k squared. And the k squared times sx squared give us kx squared. Times this gives us px squared. So this is ny squared plus nz squared times px squared. Okay? Plus nz squared plus nx squared times py squared plus nx squared plus ny squared times pz squared. And finally, we have this nx squared, ny squared, nz squared times omegas both out equal to 0. Okay, so we have this expression. Now I want to make some I need to keep the x and z component, but change the y component. Okay, here看一下啊，我需要稍微改一下这个。I can write this as ax squared p squared minus, you see now we have ny squared times ny squared times px squared plus pz squared. Okay. ny squared, and we have nz squared px plus nx squared pz squared. nz squared px squared plus nx squared pz squared. Okay, and finally we have this nx squared plus nz squared times dy squared omega squared, and plus快要成功了，差一点点。So now, this px squared plus pz squared is p squared minus py squared. Okay. And what is nz squared px squared plus nx squared pz squared? This is just equal to nx squared nz squared times kx squared plus kz squared. Okay, and this is just equal to k squared minus ky squared. And then remember here py squared is just ny squared times ky squared. Okay. So now I substitute this result into this expression. We have k squared p squared minus this. Here we have ny squared times p squared minus ny squared k y squared. And here we have nx squared nz squared times k squared minus ky squared. And finally, we have this nx squared plus nz squared times ny squared times ky squared omega squared. Okay. Plus okay. So you see here k squared我再多写一行。So this means k squared p squared minus p squared ny squared omega squared. Okay. And plus nx squared nz squared k squared nx squared nz squared omega squared. Okay. Plus n y both part. Okay. And minus对，这边有一个ny 是4方，然后减掉 nx 平方加 nz 平方 ny 平方 ny 平方，然后最后是加 nx 平方 nz 平方，对。omega 平方 k y 平方，对不对？然后再加一个这里 nx 平方 ny 平方 nz 平方 omega 40方，好，等于0。好，那你现在看呢、这个东西其实可以怎么写？其实可以。So now we have this. K squared minus ny squared omega squared times p squared minus nx squared nz squared omega squared. And now, 写这个好，写这个对好 and plus this ny squared minus nz squared times ny squared minus nx squared ky squared equal to 0。OK， 所以你看，经过转换之后变成这样，好，变成这样的话呢，这里其实这个形式啊，就是适合 我们来讨论 conical refraction 的形式啊。So this form of normal surface is suitable to be used in discussing the conic refraction phenomenon. So we see, if now I assume K to be K naught plus alpha, and the P to be P naught plus beta. Okay. Here alpha is alpha x, alpha y, alpha z. And beta is this nx alpha x, ny alpha y, nz alpha z. Okay. So what is the square of K naught? K naught square is nothing but omega square, ny square. Ny squared times omega squared. Okay. And what is the square of P naught? P naught squared is in fact nx squared P kx naught squared plus nz squared K naught z squared. Okay. However, you can treat this as nx squared nz squared times this. And we know that the elliptic equation is this equal to omega squared over c squared. So since omega over c is just a capital omega, so this is nothing but nx squared nz squared capital omega squared. Okay. So this is in fact this K naught squared, and this is in fact P naught squared. 或者是你可以从刚刚的 equation 直接令 ky 等于0，是不是就得到那个一个圆跟一个椭圆啊？这个就是圆的方程式，这个就是椭的方程式啊。所以其实这样就不奇怪啊。好，那现在呢，问题来了，就是说这个减这个要怎么表达？这个减这个要怎么表达 ？So according to this setting, then what is k squared? K squared is now equal to K naught squared plus 2K naught dot alpha plus alpha squared. Okay. However, since we consider alpha to be much smaller than K naught, and the beta is much smaller than P naught. So if we compare this term with this term, then this term can be ignored if we accurate up to the first order alpha. So we see that K squared can be approximated as K naught squared plus 2K naught dot alpha. And similarly, P squared can be approximated as P naught squared plus 2 P naught dot beta. Okay. So this means that here I can substitute this part as 2 K naught dot alpha. And we can substitute this part as 2 P naught dot beta. And if we now rewrite them in terms of the original K naught, then what is the result? Then this means that we have 4 K naught。我们这样子啊，我们把这个阿尔法呢，阿尔法 x、阿尔法 y、阿尔法 z 呢，给它写成 c eta zeta。According to the notation in the textbook, we write alpha x, alpha y, alpha z as c eta and zeta. Then this means that now we do not have the y component here. We have c and zeta. Okay, so we have k naught x c plus k naught z zeta. And how about this part? This part, both p and beta has the nx, ny, nz factor. So now we have nx squared. Okay, k naught x c plus nz squared k naught z zeta. Okay, and finally we have this. Sorry, here we have omega squared. Okay, we have this omega over c squared times ny squared minus nz squared, ny squared minus nx squared times eta squared equal to 0. That's because k naught y is equal to 0, and the variation of the variation of ky is eta, and eta is just equal to ky. Okay. So finally we have this equation, and this equation is just the equation listed in the textbook 4.8-6. The textbook has an error. The author forgot this factor, omega over c squared. And what does this equation mean? You can try to diagonalize this part and give us something like this. C squared over a squared plus zeta squared over b squared equal to something like this, eta squared. And this equation describes a cone. Okay, a cone. And this coefficient can be found in the notes I gave you last week. Okay, 我上礼拜有给你们这个 note in that note there is every detail to derive the final result in the textbook. Do not afraid this very complex topic. In the midterm exam, I will not test you the memorization of all these details, but you should understand the mechanism of conic refraction. Okay? 所以我们下礼拜呢，我们就考期中考，考试的范围就到我今天所讲到的范围。好 ，OK。